So let's go ahead and get started. I guess all those other people are still in bed. Maybe they'll join us later. So this is Cisco Enterprise Mobile Collaboration, or BRKUCC 2060. I'm Matt Jordy. I'm a technical marketing engineer at Cisco. Been here quite a while. Predominant area of focus for the last long time, 18 years plus, has been collaboration, and in particular, mobile collaboration. I've been doing quite a bit. Has anybody ever been to one of my mobile sessions? Everybody's first time? Oh, cool. So it'll be all new for you guys. That's good. Okay, so let's jump in here. Here's the agenda. I like to always review it at the beginning. What we're going to do today is I'll start out with a quick overview of what I mean by mobile collaboration and some of the terminology that we're going to use. Next, we'll jump in and talk about on-premise mobile collaboration with deployments that begin on-premise. We'll talk about architecture, features and functions, and then design and deployment considerations. We'll then step back and talk about cloud and hybrid and go over the same topics around cloud and hybrid, talk about things like WebEx Teams and those kinds of things. And then lastly, I'll sort of summarize everything up and get you on your way. A couple of things from a logistical perspective. My expectation is you do have some familiarity with these solutions, and that you have a pretty good understanding of IP telephony generally, communication manager, those kinds of things. That's all pretty central to everything that we'll talk about. Even though we'll move from unified mobility and sort of fixed mobile convergence, we build upon that as we move through this presentation. So my expectation is you have some of that background. Also have quite a bit of material, and we didn't have time to cover everything, so I put some stuff in the appendix. So there'll be some stuff I don't cover today, and certainly you can refer to that information in the appendix. Session time is 120 minutes, and I will use most of it. I won't save time for questions at the end. We'll just take questions as we go along. It makes it more interactive, that kind of thing, so I prefer to do it that way. So please ask questions as we go along. Just raise your hand or call out my name. I do break questions down into sort of 3 categories whenever I present. There'll be questions that I'll answer right when you ask them. There'll be some other questions that you may ask that I've got a slide or some slides that cover it later on, and so I may defer those questions to a little later in the session, and we'll come back to that. There may also be some questions I don't know the answer to, or questions that are sort of out of scope or that would just take too much time. So for that last set of questions, please come see me after the session. You can also send me an email or a WebEx Teams message. My email address, M as in Matthew, Jordy @cisco.com. So you can always reach out to me with any of those questions. But yeah, I've had people ask, hey, I've got this problem with my network. Can you tell me what the problem is? And we don't have time to do attack troubleshooting, for your individual issue. So I may off the top of my head have some ideas, but ultimately, I'm going to ask you for logs if you really want to get into it, and we don't have time to look at logs. So anyway, please ask those questions as we go along, and just be aware I may have to punt some of them to later. Okay. One other thing I always like to remind people, this is a snapshot in time. All the information I'm providing you in the deck today is accurate as of 5 minutes ago. However, as we know, things change, and especially in the cloud space, they change pretty rapidly. So always a good idea if you refer back to this down the road, maybe just do a double check between this material and the latest and greatest release notes for the latest and greatest software, because sometimes things change, and I don't want you to take my word for it if there's something newer. So always look at the newer material if it's available. A couple other things before we jump in. There is a WebEx Teams space for us to be able to collaborate. You can ask questions of me, and other people can also join and see what other questions are asking. So feel free to join that, and I'll be able to answer any questions after the session you may have. And some of your colleagues that are here in the room may be able to answer them before I get to them, and that's fine as well. But we can communicate that way. Also, there's a survey. You've probably heard this a lot and seen this slide. Please do fill in your surveys. This is really, really important, particularly for me and for this session. I've been offering this session for a really long time, and it has morphed, and we change it all the time. But I would love it if everybody here said, it was the worst session ever, don't ever let that guy present again, because then I won't have to come back. No, but in all honesty, we do look for your feedback based on what you tell us. We either tweak it, we get rid of the session, we change it completely, we add material, we take away material based on your feedback. So your feedback is important. Otherwise, I just sort of make it up as I go along and talk about what I want to talk about, but I'd much rather talk about what you want to talk about. So do provide that feedback. All right, so that sort of gets all the logistics out of the way. So let's jump in and talk about mobile collaboration from an enterprise perspective. So from a session perspective, what we're really going to do here is sort of talk about and describe enterprise and cloud collaboration mobile apps and services, which the idea is to enable anytime, anywhere collaboration for our mobile users. So the session's going to focus on really two main things: on-premise deployments, and there we'll be talking specifically about Cisco Jabber, as well as unified mobility capabilities, and then cloud and hybrid deployments, and that's where we get into starting to leverage the cloud and/or cloud and on-prem together, and we'll talk about there Cisco WebEx Team predominantly, but also some Cisco Jabber comes into play there as well. And of course, these features and functions and these deployments are delivered through two basic types of integration. The first we call fixed mobile convergence, and I'll define that a little bit later so everybody's clear on that. But that's really where our unified mobility communication manager feature set comes into play, things like single number reach. And then fixed mobile substitution, and that's where our mobile clients come into play. And we start to put software on our mobile devices, on our desktops and those kinds of things to enable additional features and services. And the whole idea behind all of this ultimately is to provide a set of comprehensive collaboration features to provide reachability, persistent reachability, and continuous collaboration for all of our mobile users while they're moving around in various locations, so wherever they're located. And so in summary, and you'll see me come back to this a few times, but the whole idea behind mobile collaboration is really to provide any collaboration service, whether that be calling, messaging, meeting, share, whatever those things may be, across any device, whether it be smartphone, a tablet, desktop, even web interfaces from a web browser, and then to be able to do that no matter where we are located, whether we're at home, whether we're in the office, whether we're on the go, and also how are we connected to the network, whether we're connected over Wi-Fi or a wired connection. If that's Wi-Fi, is it public, is it private, or is it mobile data? Maybe we're connected over the mobile data network. But the point is, no matter where I'm located, no matter what device I have, I should have access to any of these collaboration services. And so that's the whole thing and sort of the theme of what it is that we'll talk about today. So keep that in mind as we talk through here and be thinking about that. So from a sort of high-level overview, our mobile collaboration solutions from Cisco really involve two things: unified mobility, which you've heard me mention a couple of times, fixed mobile convergence, and I'll define that again in just a second, and then Cisco mobile clients. And again, the idea here is providing any of these collaboration services on any of our devices, and again, whether we're inside or outside the enterprise, no matter where we're located. And so that's, again, over Wi-Fi, over the mobile data, over the PSTN, all those things we're talking about here. So I've said fixed mobile convergence and fixed mobile substitution a few times. So let's jump in and talk about what do we mean by fixed mobile convergence. Well, typically in the traditional sense, it's taking your fixed telephony environment inside the enterprise and connecting that to the mobile, the PSTN, that ability for people to be able to be anywhere and be able to call. And so the idea behind fixed mobile convergence is really integrating or linking the user's enterprise line to that public network, the PSTN or the mobile network, and be able to allow a user to be able to have an enterprise line sort of linked to that mobile device so they can be reachable there. And so the solution that we use to provide fixed mobile convergence is Cisco Unified Mobility. It's been built into Communication Manager since way back in Communication Manager 5 days. It's a feature set within there. Provides a number of things. The first one that most people are commonly aware of is a single enterprise number for all of their enterprise calls, whether they're taking that on a mobile device or whether they're taking it on an actual physical desk device within the enterprise. That's what we're doing. That single enterprise number, of course, is the enterprise number. When we talk about single number reach, it's the enterprise number, not the mobile number that we're talking about, but we're tying those two things together. The other thing that we get with unified mobility is the ability to dial enterprise calls from that mobile device or from that PSTN device. So the ability to make it look like I'm dialing from inside the enterprise. And then the best thing about unified mobility is, with fixed mobile convergence and these capabilities, I don't have to have any special hardware or software in the user's hands. They can have any mobile device, any PSTN phone that's available on the PSTN network or the mobile network is going to be able to be used with unified mobility. I don't have to have any special software. I don't have to have a special provider. I don't have to have a special device. I can really do this with pretty much anything. All right. So that's unified mobility. What about the feature set itself? So a number of things that come into play here in terms of that feature set. Single number reach is the one most people are familiar with. Again, your enterprise number is your single number. Whenever a call comes into that enterprise number, we're going to ring not only the enterprise device, the desk phone, for example, but we'll also fork that call out and ring out to the PSTN to ring that mobile device or other device. Right? And then the user can answer on either device, and then they can have their call. Call filtering, so when we extend those calls out to the mobile device or to that PSTN device, we can actually filter based on caller ID, time of day, so it gives users the flexibility to determine what calls are going to come through and reach them. Have mobile voicemail avoidance. This is going to be important so that if a call does get extended out to my mobile device and I don't answer it, we want to make sure that it ends up in the enterprise voicemail system, not in my mobile voicemail system, so we don't have to check two different voicemails. Enterprise two-stage dialing, this is the ability for us to be able to dial through the enterprise from that mobile device, right, as if I am a enterprise user. So when I call through the enterprise, the caller ID that the people are going to see is going to be my enterprise number, not my mobile number, even though I made the call from my mobile. And then the ability, once I have an active mobile call, the ability to move that call back and forth between the mobile device and my desk phone and vice versa. So a bunch of features and functions built into this. And what you'll find is, and we won't spend a lot of time here, I've got one more slide on unified mobility and fixed mobile convergence, and then we're going to move on and talk about clients. But it's important for us to remember all of this stuff because this is fundamental to everything that we'll talk about going forward. We actually build all the client capabilities on top of this unified mobility feature set. So one thing I want to bring up, which is new, I normally don't spend any time on unified mobility other than to do just what I did, but there was one new thing that came with version 12.5, which was just out and released a week and a half ago, and that is the ability to support native VXML for mobile voice access. Mobile voice access is a two-stage dialing capability, and it's an IVR-based capability. So what normally happens is a user is going to dial a number, which is the enterprise number, some service number within the enterprise, and then once they get connected to that number, they're then going to be prompted to enter the number they actually want to call, and then they enter that number, and the call gets extended, and then media is connected between the two devices. So that's why we call it two-stage. First stage is dial the enterprise service number. Second stage is extend that call out to the number that we call. So this is two-stage dialing. Part of mobile voice access, part of unified mobility, and the idea behind mobile voice access is IVR-based. So when the user dials in, they're actually prompted with an IVR or a voice response to ask them to enter that number. In the past, traditionally, the way that IVR capability has been delivered is through a VXML gateway, and that VXML gateway is always run in iOS. Right? So prior to 12.5, you had to run your gateway or your VXML capability on the actual iOS gateway, and there would be interchanges between Communication Manager and that gateway to pass those IVR and VXML information back and forth so that the user could navigate that script. The problem with that up until this point is that our iOS gateways that support native VXML, ISR G1 and G2, are all end of sale, end of life. So today, if you wanted to do mobile voice access, you could not buy a gateway that supports VXML for that capability. The ISR G3 or Cisco 4000 series, those are all not supporting VXML. So to solve that problem and to allow people to continue to use mobile voice access, we actually implemented in 12.5 the ability to have native VXML capabilities within Communication Manager. So now I can continue to do mobile voice access without the need to have that outside separate iOS gateway. Does that make sense to everybody? Yeah. Okay. All right, so for anybody that's doing that, that should be pretty helpful. All right, so again, done with unified mobility, but again, remember everything we talked about because we are going to build upon single number reach and some of those capabilities. So fixed mobile substitution, that's the other side of the coin here. What do we mean by fixed mobile substitution? This is actually taking fixed mobile convergence and taking it a step further. So rather than just linking the mobile device to the enterprise line, what we're actually going to do is actually move or enable that enterprise line onto the mobile device. So it's not just a case of linking it, but we're actually going to move that line onto that device so that the device, for all intents and purposes, becomes your enterprise device. Right? But when we do this, there are some additional considerations that we need to think about. It's not as easy as unified mobility, any phone, just put the number in and it's all good. In this particular case, we're going to need a piece of software or an application running on that mobile device in order to enable that enterprise line on that device. Right? So now we start to get into clients, Cisco Jabber, Cisco WebEx Teams, something running on that device to make that happen. And that introduces a new thing, which is we have to have some form of IP connectivity. When we talk about enabling that enterprise line, we're talking about an enterprise IP telephony line, so it needs to be IP connected. And so that's where we get into having some form of data connectivity, whether that be wireless LAN, or whether it be mobile data, or maybe it's both. And from a deployment perspective, as an administrator, I need to make sure that I'm aware of, okay, am I going to provide Wi-Fi for my users, or do I need to make sure that they all have a mobile data plan on their phone so that they can leverage mobile data? So those are the kind of considerations that we need to think about. The other thing is, and this is where the fixed mobile substitution comes into play, the substitution piece. If I'm enabling the enterprise line on the mobile device, do I actually need an enterprise device, an actual physical hard desk phone? And I think the answer there depends. In some cases, no. If you have a highly mobile worker, maybe the mobile device is all they need. On the other hand, if you have somebody that's in the office at least some of the time, it might be nice that when they step into the office, they have a nice hardware endpoint, maybe a video endpoint with a big screen on it and all that kind of thing. But there's no reason why I can't have fixed mobile substitution without a physical hardware device beyond my mobile device. And so many customers have this scenario where they have users on their system, but the only way their users connect in is through Cisco Jabber, for example. They don't actually have a physical phone. So that's fixed mobile substitution. And so again, we'll spend the majority of our time for the remainder of this session really focusing in on fixed mobile substitution and the clients that enable that capability. And so in terms of looking at this from a feature functionality perspective, again, fixed mobile substitution and these clients solutions actually build on unified mobility. We'll leverage things like single number reach and those types of things. Again, have to have software installed on the device. And when we talk about mobile devices here, and I should clarify that now, I'm not only talking about smartphones and tablets, but I'm also talking about desktops that can be mobile as well as like web browsers, depending on where you might be. And so again, we're moving the enterprise line onto the IP phone, and we're going to enable enterprise telephony features there. Right? And what specific features? Enterprise voice and video calling is certainly the main reason that we do this. But the nice thing about a lot of the clients that we're talking about is they enable a lot of other collaboration besides just voice and video. So things like messaging, presence, file sharing, those kinds of things, enterprise meeting, calendar, and directory services and the integrations there, so people can start to look at contacts from the enterprise directory. They can do meetings and get meeting notifications and those kinds of things, all built into that application. So it becomes more than just the traditional telephony perspective and adding additional collaboration features and functions. And then, of course, the big key is secure remote attachment. It's all well and good to deliver all this, but if I can't connect securely into the enterprise to leverage those services, then I'm sort of dead in the water. So we also have to provide capability for them to remotely connect into the enterprise systems. All right, so what client specifically are we talking about? Well, first off, Cisco Jabber, whether it be running on an Android, an iOS device, or on a desktop. It's providing SIP-based voice and video capabilities, yes, but also XMPP-based IM and presence, visual voicemail, file sharing, screen sharing, and then again, the ability to securely connect to the enterprise to leverage those services. So that's one thing that will come into play. Next is WebEx Teams for Android, iOS, and desktops. Again, similar to Jabber, it's just a cloud registered rather than an on-prem registered device, but it provides many of the same capabilities, voice and video capabilities for calling, messaging, file, and screen sharing, and those kinds of things. There's also some other clients that will come into play. Cisco WebEx Meetings, enabling us to have on the mobile devices and our desktops the ability to access WebEx Meetings. Cisco Meeting App, which enables the same type of functionality for on-prem meetings with Cisco Meeting Server, so on-prem meeting capabilities. And then Cisco AnyConnect, which allows us to securely connect in from these devices using VPN into the enterprise. And we'll talk a little bit more about that. The main area of focus, though, that we'll spend today is talking about Jabber and WebEx Teams. I'll mention AnyConnect a little bit from a VPN perspective, but for the most part, we're going to focus on these two clients. And then again, I'll remind you, as we talk through this, new versions of these clients come out all the time, so it's always a good idea to refer back to the product documentation after you leave here today, because things do change. All right, so that was sort of our overview. And want to make sure no questions before we move in and dive in, because we're going to start to move a little faster and dig in a little deeper. So any questions? No? All righty, so let's start in here and talk about architecture. So as I mentioned, we're going to talk across a number of different types of deployments, whether they be on-prem, whether they be some combination of on-prem and cloud or a pure cloud. So from a Jabber perspective, as we jump in here, Jabber is capable of being an on-prem client and leveraging services from on-prem, whether that be calling, messaging, et cetera. Jabber can also, and we'll talk about this in a little more detail later, can also take advantage and be a cloud-based client. It can leverage services, at least some services, from the WebEx cloud, including messaging and meeting capabilities. And then what we often see is sort of a combination of the two of those, the best of both worlds, a hybrid type of deployment, where that Jabber client is leveraging things like calling from the on-prem enterprise, and then leveraging things like messaging, perhaps, from the cloud. So a hybrid capability where I'm mixing and matching those types of things. And the idea is that we can do that with Jabber across any of those types of deployments. So I want to jump in here and talk about a little bit in detail what we're getting with Cisco Jabber and these mobile clients. And as I said, the big thing that everybody does this for, fixed mobile substitution, is really the ability to allow enterprise calling, in this case voice and video calling, from that mobile device. So our Cisco Jabber clients are going to register to Communication Manager just like a regular hardware endpoint. Signaling is going to be SIP, and our media is going to be SRTP or RTP, depending on whether we're doing secure or insecure. From a codec perspective, we do G711, G722, G729, and Opus, and our video codec is H.264 across the board. Now notice here, as I mentioned at the bottom corner there, all of this IP signaling, all this media, again, has to go over some form of IP network, and that may be your Wi-Fi, public, private, or it could be mobile data. So be aware of that. Then the other thing, a cloud side thing, is Cisco WebEx Teams. Our mobile clients registering to Cisco WebEx. Now they're a mobile device, which is a cloud calling device as opposed to an enterprise calling device. But the idea is still the same. Signaling in this case, rather than SIP, because it's cloud, is going to be HTTPS, or REST-based, and our media is again going to be RTP. Pretty simple from a codec perspective. We just support Opus with the WebEx Teams client, so we can do interop with on-prem because they all support Opus as well, and then our video, again, H.264. So that's the calling aspect of it. Next thing we want to talk about at a high level is around instant messaging and presence. Again, Jabber can leverage on-prem instant messaging and presence and file sharing capabilities using IM and Presence server, using an XMPP protocol in order to be able to do that. WebEx Team can also do IM or instant messaging and activity presence type of capabilities along with sharing using the cloud. And in this particular case, again, HTTPS is what we'll use. And you'll notice as we go through here, all of the WebEx Teams communication between WebEx Teams and the cloud, and even some of the hybrid stuff that we'll talk about, we always talk to the cloud using HTTPS. That's sort of the standard method by which we talk to cloud services. But on the enterprise, we can be a little more fancy and do things like SIP and XMPP. So those are our messaging capabilities. One other thing I want to talk about, though, is hybrid messaging. And this is where, as I mentioned, sometimes we can have Jabber leveraging both on-prem services and cloud-based services. And so Jabber does have the ability to leverage IM and Presence and file sharing capabilities from cloud-based services. And so we can do XMPP-based flows to cloud-based WebEx Messenger. And this has been around for quite a long time, this capability within Jabber. But we recently added a new capability called Jabber Teams Messaging Mode, which is basically Jabber leveraging cloud again for IM and Presence services, but rather than leveraging WebEx Messenger, we're now leveraging WebEx Teams messaging, which is a different sort of messaging capability, different part of the WebEx cloud, and is more aligned with the WebEx Teams client capabilities. And that's called Jabber Team Messaging Mode. Again, it's new. It's just come out in the last month or so. I'll give you a link here to a deployment guide around 12.5 for Jabber. There's a whole section that covers off this Jabber team messaging, and you can find all the details in there. I'm not going to go into any more detail about it than that. One thing to point out, though, that Jabber messaging mode today, team messaging mode, only supported on the desktop with 12.5. In the next month and a half, we expect it to also be available with Jabber 12.6 on the mobile devices. You can actually try and use it on the mobile devices, and it works a little bit, but tend to have a little bit of issues. So just be aware with the team messaging mode, this is kind of new. So if you want to run it on your mobile devices, your smartphones, your tablets, you're probably going to need to wait for a couple of months before it becomes available on those mobile clients. But you can certainly look at it as a desktop if this is something you're interested in, kind of trial it and see what it looks like from a desktop perspective. All right, one other thing I want to talk about with messaging, and that is around interop. So one of the things that we sort of have a challenge with is if we have an on-prem deployment and I want to start deploying some of this cloud capabilities, I need to be able to have some kind of interop between my on-prem users and my cloud users. And without that interop, it makes it really hard to sort of migrate over there. It's more of a flash cut. Okay, I'm going to put everybody from Jabber onto the cloud tomorrow, and nobody ever does that, right? That's a way too big a switch over. So we need some form of interop so that my users that are using Jabber can communicate with those users that are doing the cloud. So we have ability to do that, and there's two methods for doing that. One is WebEx Hybrid Message Service, and this is also a new thing that we have recently coming out, and that is using message interchange between IM and Presence and XMPP-based Jabber IM and Presence, and then being able to allow those users to do message interchange through a message connector to users that are connected to the Cisco WebEx messaging side of things. So they're using HTTPS, the Jabber users are using XMPP, and then there's interchange between those facilitated by that message connector. And again, this is going to be important as we move some users potentially from on-prem to the cloud. We need to be able to communicate and intercommunicate. We also have the ability to do this with cloud-based Jabber and WebEx teams, and this is where we have Jabber using WebEx Messenger, and then we have WebEx Teams users using WebEx Teams messaging, and so we need cloud message interchange. And so that's built into the WebEx Cloud is the ability for users that are using WebEx Messenger to be able to communicate with users in your org that are using WebEx Teams messaging. All right? So that capability has been there for a while and allows you to be able to do that kind of thing. All right. All right, let's move on then. Okay, so let's jump in and talk about some of these features and functions. So we're going to take a step back to unified mobility. As I mentioned to you when we talked about the client piece, all of the client functionality tends to build upon unified mobility and the capabilities that are there. So with a standard unified mobility user, we have what's called a remote destination profile. And this is a person without any clients, any mobile devices, and that kind of thing with Jabber. And really, we're just talking about just a basic user. They have a remote destination profile, which is a virtual phone within Communication Manager. And that virtual device is going to share a line or have the same directory number as the desk phone that that user has. And so that's going to basically tie that remote destination profile and the phone together. And then the second piece of that is we need to define our mobile number or our PSTN number, the number we want to be reached on. And in this case, that's going to be our mobile number. And I can actually specify up to 10 numbers such that anytime a call comes into my enterprise line, I'm going to ring out to up to 10 numbers. Now, typically, we're not going to do that. Most people don't have 10 devices they need to ring. Mostly, it's just one device, and it's usually going to be your mobile device. So this is the way that we do normal unified mobility single number reach. The same idea applies when we have a Jabber dual mode device, a mobile device, having both a Wi-Fi capability or a IP capability as well as a mobile data capability. And so in this particular case, we're going to define a client device type within Communication Manager. This is our Jabber dual mode for Android, dual mode for iPhone. And in this particular case, we don't need a remote destination profile. Instead, we're going to associate those remote destinations or those mobile numbers to the actual device within Communication Manager rather than a remote destination profile. Again, even with the Jabber device, I can specify up to 10 off or remote numbers, PSTN numbers for that Jabber device. Again, normally I'm only going to define one, maybe two. I might put my home phone on there, for example, but generally speaking, it's just a single number. Now, one of the things you'll notice here is that normally in a standard unified mobility scenario, we have what's called remote destinations, 1 through 10. But the very first number that we configure under a Jabber client or a dual mode client is going to be what we call a mobility identity. Now, what's a mobility identity? Mobility identity is specifically related to this fixed mobile substitution. And the reason that it's important is because it provides a special function, a couple of special functions. First, it enables dual mode handoff and the ability to move a call from the Wi-Fi interface to the cellular voice interface. Allows us to do dial by office, which we're not going to talk about today, but is automated enterprise dialing with an application. But the bigger thing that it provides is the dual ring avoidance. And I'm going to talk about dual ring and avoidance in a minute, but the whole idea is if I configure my mobile number as a mobility identity on a Jabber client, I'm going to get some additional capabilities. So what is dual ring avoidance? So let's take a user who's been configured for unified mobility. They have Jabber, and they've also been configured for single number reach and all of that. So you can see up here I have a user with an enterprise number, and I have 2 instances. It's the same device configured as both a Jabber device or a mobile device, but also configured as an enterprise line. So it's registering the communication manager, but it can also receive calls via single number reach. All right? Now the problem is that's the same device, so if I get a call on my enterprise number, in theory, I'm going to ring it both by IP because it's got a Jabber client on it, but I also have single number reach configured, so single number reach can kick in and ring the cellular interface of that device. And what that means is I'm now going to get a call on my enterprise line that's actually going to ring in both via IP as well as on cellular voice, and that's a problem. It means I'm going to get a ring in twice. And that's a bad user experience. The user gets 2 calls, which one do I answer? If I answer this one, I don't know, whichever one came in first. And then if I do answer the one and the other one comes in, now I'm getting a call waiting, so I got to go hang on and cancel the other one. It becomes a really confusing thing. So dual ring avoidance and that mobility identity actually prevent that from happening. So let's look at this and see how it actually works. So in the case when an incoming call comes into the system for that enterprise number, and whether it come from out in the PSTN or it's originated from inside the enterprise, that call is not going to get routed out to the cellular interface, or it's not going to engage single number reach if the mobile client is registered. All right? So in this particular case, my device is registered, the Jabber client is registered to Communication Manager. I have an IP path to Communication Manager, so we're going to ring it just like we would a regular desk phone. Right? But what happens if that device is not registered via IP? In that particular case, that same call will now route out using single number reach out to the PSTN to ring the cellular interface. All right? So the way this dual ring avoidance works is whenever a Jabber device is configured with that mobility identity, then we always first check to see if the device is available via voice over IP, by the IP path, and if it's not, then only then do we then extend the call via single number reach out to the cellular interface. And the idea here is then, of course, to prevent that dual ring. So check and see is Jabber registered? It's not registered. Okay, now I'm going to ring out to the cellular interface. If it is registered, then I don't need to bother ringing out to the cellular interface. So that's the dual ring avoidance, and that's why that mobility identity is so important. But again, all of the functionality that we're talking about here, single number reach and all that capability, is just unified mobility. And this is what I mean by us building on top of unified mobility with these clients. Right? Now there's one situation in which I'm still going to get dual ring in these scenarios, even though I've configured a mobility to anybody. Anybody know why I would get dual ring in some scenarios? Anybody? Well, no, not Jabber, not up, but what happens if somebody calls my cellular number directly? So again, all of this we're talking about is a single number, your enterprise number. So this happens when somebody dials my enterprise number, but what if my mom calls my cellular number, right? And at the same time my mom calls my cellular number, my colleague calls me on my enterprise number. In that situation, I'm still going to get dual ring. And the reason for that is because Communication Manager and the enterprise have no visibility to what my mom's doing in my cellular interface. All they know is I can reach that user on their cellular interface, and I won't reach them on the cellular interface as long as they have IP connectivity, but I have no way to know, is there a call on that cellular interface? So there are some situations, as I say here, where an incoming call could ring on both interfaces, but if somebody dials your enterprise number, it's only going to ring on one or the other. Make sense? Okay. All right, so next thing we want to talk about is secure remote attachment. Obviously, it's all well and good for us to be inside the enterprise with our Jabber client or our desk phone, but the whole idea here is what about our users that are moving around? Any location, right? No matter where they are, any service, any device, any location. In order for them to be in any location, I have to provide secure connectivity into the enterprise. So how do I do that? The traditional way we've done it is through VPN, using some form of VPN capability to create a secure connection back into the enterprise. And we do that with a VPN iOS router, Cisco Virtual Office, for example, and as I mentioned earlier, Cisco AnyConnect. So that's where your AnyConnect client on your mobile device would come into play to allow you to connect in securely to the enterprise. So that's one option, and that's the traditional option that people typically use. But we've also got built into Jabber and our solution the ability to do VPN-less, or what we call collaboration edge connectivity, using expressway, mobile, and remote access. So what this is going to allow us to do is to be able to connect in to the enterprise securely, but only for collaboration services. So with VPN, we send everything over that tunnel. Unless we're fancy and we do split tunneling, typically when you do VPN, everything from that mobile device is going to go across the VPN tunnel into the enterprise, and then may end up getting routed back out to the internet if it needs to go that way. In the case of Collaboration Edge, only thing that we're going to allow to go over that secure connection is going to be call signaling, IM and presence capabilities, visual voicemail and directory services, and then voice and video media. So all of that stuff is going to travel over that secure connection. Anything else is going to go directly out the local connection to the local network. So unlike VPN where we send everything, in this case, just the collaboration traffic is going to go through the enterprise. So the mobile and remote access and this whole firewall traversal in order to allow the secure connection is new for most people. So I want to quickly go through sort of how expressway firewall traversal works, because this is part and parcel to being able to allow mobile and remote access to work. So the way that mobile and remote access works is we have an expressway E and an expressway C. They're always deployed in pairs. Expressway E is going to be the traversal server, and it's going to be installed in the DMZ. So we'll put that in our secure DMZ. And then we have Expressway C, which is our traversal client, and is going to sit inside the internal network. And the first thing that happens when we set these up is Expressway C is going to initiate an outbound connection through the firewall to Expressway E. And they're going to do that through a specific port, and they're going to do that using secure credential and certificates. So once they've established that connection, then Expressway C is going to send a regular keep alive out that port to Expressway E to keep that connection open. Okay. So at this point, we now have an outbound connection from Expressway C to Expressway E, and Expressway E is now listening out on the internet for any incoming requests, whether they be calls, presence, messaging, et cetera. We're now available and open to be able to accept calls for those services. So once a connection comes in from outside, what's going to happen is it's going to get forwarded to Expressway E. Expressway E is then going to forward that, assuming it's who it's supposed to be, is going to forward that through that connection, that outbound connection that's already open, is going to send that connection into Expressway C. And then Expressway C inside the enterprise network is going to take care of communicating with any back-end servers and collaboration services. So in this particular case, it's a call. So Expressway C is going to pass that on to Communication Manager, which is going to locate the endpoint we're trying to call. And then once that signaling path has been set up, then what's happened is we will then cut the media through, and that media will leverage that same outgoing port that we already had open. Right? And that's going to allow us to do secure traversal through the firewall. And keep in mind, from the inside perspective going out, that outbound connection is no different than a web browser inside your enterprise, leveraging that outbound web connection out to the internet. So if you don't allow that, you may need to do some firewall stuff, proxies and all that kind of thing. But the idea here is it's no different than an HTTPS connection coming out of your enterprise. So that's how mobile and remote access works generally. Right here I'm showing you a call, but the same idea would apply if we're doing visual voicemail and we want to get a voicemail over mobile and remote access, or we want to send an IM and presence message. Those things are going to happen exactly the same way. They're going to hit Expressway E passes it on to Expressway C, and then Expressway C talks to IM and presence or to your Unity connection box in order to allow those communications. Right? So that's mobile and remote access, allowing that secure remote attachment for our clients. All right, so let's take a look at what this actually looks like when a Jabber client is out there and how this sort of works from an inside and an outside perspective. So first off, let's say that Jabber is inside the enterprise. So in that particular case, the way this is all going to work is Jabber, whenever it logs in for the first time or whenever there's a network change, it does a DNS query. And it looks for a number of records within the DNS server when it does that query. It's going to look for Cisco-UDS and looking for an SRV record for that. That record should map to a communication manager within the enterprise. They'll also do a search for collab edge, _collab-edge, and that's looking for TLS protocol that's available from Expressway. So when we're inside the enterprise, the idea is that when I do that DNS query from the Jabber perspective, I'm going to get resolution on Cisco UDS. I'm going to find my communication manager, and I'll be able to directly connect to that communication manager. What I won't get resolution for, or what I shouldn't get resolution for, is the collab edge or the Expressway. Because I'm inside the enterprise, there's no reason for me to use Expressway. So in the corporate DNS, I have my UDS SRV record, but I don't have a collab edge record. So in that particular case, the user's inside, Jabber client's going to connect in directly to those collaboration applications. All right, now what happens if then I step outside? So in that particular case, I'm still going to send the same DNS SRV queries, but the difference is now I'm not talking to the corporate DNS, now I'm talking to the public DNS. And in the public DNS, I want to make sure that I never get resolution for Cisco UDS, and I shouldn't because that's inside and shouldn't be reachable from outside. But I should get resolution for collab edge, and that collab edge resolution should point me to a valid Expressway E. So in this particular case, I'm getting pointed to my Expressway, and now I'm going to connect in over Expressway mobile and remote access. Right? So what we're actually showing you here and defining here and what makes this work is what's called split DNS. Corporate DNS has all my collab application SRVs. Outside, DNS only has the Expressway DNS SRVs. Right? And that's how we're able to know whether we connect directly or whether we connect over MRA. What about when we connect over VPN? So some people may not want to do MRA, they may want to do VPN because they need connectivity for other reasons. And so in that particular case, the idea is going to be exactly the same as on-prem, right? I'm going to send those same DNS queries, but in this particular case, because I'm connected over VPN, I'm going to get Cisco UDS, but not collab edge, and so I'll connect directly to those collaboration applications over the VPN tunnel. All right, any questions on that? No? All right, cool. All right, so in terms of how it is that we make all this mobile and remote access work, obviously DNS is going to be huge, split DNS that we just talked about. There's a couple other things we need to think about as well. Certificates. Obviously, because we want this to be secure, we're going to leverage certificates. That's how we secure most things within the collaboration space. Normally, all of our collaboration applications have self-sign certificates. Our recommendation usually is to sign those certificates using a CA. Most of the time it's an enterprise CA because you own it and can control it. But the whole idea of signing certificates is so that I minimize the amount of certificates that I have to exchange. I sign it with one CA, I pass that root certificate around, and I'm good to go, and everybody gets trusted. And so normally our recommendation is sign your collaboration application certificates, communication manager, Expressway, all of that, sign it with your enterprise CA. There's one exception to that though, and that is the Expressway E certificate. The Expressway E certificate must be a publicly signed CA certificate. It must be signed by a GoDaddy or all of those various CAs out there, VeriSign if they're still around. So you need that one signed by an Expressway E or by a CA. Now, there's one exception to that. People always go, I really don't want to have to deal with that. I don't want to have to sign with the public CA. It's such a pain. Can I not use an enterprise CA signed certificate? And the answer is you can for Jabber clients. Because of the fact that we have the ability with our mobile clients to be able to control the trust store on those mobile devices, we can actually take that enterprise CA certificate, root certificate, and I can actually put it on the mobile device. And therefore, I can actually leverage an enterprise CA signed Expressway E. The challenge though is if I have any desk phones that I want to connect over MRA. We have the ability with some of our desk phones, our 8800s, our 7800s, and our CE video endpoints to be able to register over mobile and remote access just like Jabber and leverage these same capabilities. However, on a hardware phone, I have no ability to insert a certificate into that trust store. That trust store is built into firmware, and it only has public CA root certificates in it. So as a result of that, if I'm going to do any kind of hardware phones, that's where that requirement for a public signed Expressway E certificate is. So in theory, if you're just doing Jabber over MRA, you could get away with an enterprise CA signed certificate. But from recommending is public CA. All right. Capacity-wise, this is obviously important to know how many users am I going to have connected over MRA, and I need to know, one, how many are going to be registered at any given time, and then I also want to be concerned about how many calls, whether it be voice or video, I'm able to push through Expressway mobile and remote access. So we can have a maximum of 10,000 proxy registrations per Expressway cluster, and I'll talk a little bit about clustering in a minute. But 10,000 is what the sort of high-level limit is, unless you're using the new CE 1200 Expressway platform, which allows you to actually double that to 20,000 per cluster. Right? But keep in mind, from a voice and video call perspective, it's 2,000 video calls simultaneous and 4,000 voice calls simultaneously, or some combination thereof. So if you have 20,000, if you're using a CE 1200, even though you may have 20,000 users registered, you're still got the 2,000 and 4,000 limit that you need to contend with. So you may not need to register 20,000 users or devices over that. It all depends on your call flows and rates and all that. So that's capacity that we need to think about. High availability, and this is where we get into the clustering piece with Expressway. So we cluster just like we do Communication Manager. We can add additional Expressway nodes, both on the Expressway C and on the Expressway E side, in order to be able to scale and to provide redundancy. We always want to make sure that we deploy our Expressway Cs and our Expressway Es in equal numbers. So if I have 2 Expressway Cs, I need 2 Expressway Es. Again, we're always pairing them together. And then I'm always going to want to have at least 2 of each type of server so that I have some form of redundancy. Expressway clusters cluster in a 4-2 type of environment, so I can have up to 4 sort of active Expressway nodes. And that's where we get into the 10,000, 2,500 proxy registrations per node. I can have up to 4 of those, and that's where I get to the 10,000, or if it's 5,000 if I'm doing a CE 1200. So that's how the redundancy scheme works. Our Jabber connections over those, over MRA and over those Expressways are going to get reestablished automatically. If I lose an Expressway E or a C, I can route around those with my clients. But there are some things that we need to understand in terms of that capability, in terms of redundancy. So we have the ability for IM and presence capabilities over MRA to be able to fail over when we lose an IM and P server in the background. We can fail over to a backup IM and P server. However, for a Unified Communication Manager and Unity Connection, any failures of a node that you're registered to over MRA will not fail over to the backup. And that's just a known defect. It's been a defect for a while. It's something that has been on our backlog and just hasn't been addressed. The way to get around that is that the user simply needs to log out and then log back into the client, and that will allow them to connect over the backup Communication Manager. But that's just one nuance to be aware of from a high availability perspective. But otherwise, Expressway E and C nodes, when those go away, we can always route around any of those types of failures. And any IM and presence failures, we can also route around. So that's that. One last thing here, and this is just sort of a comparison, and this is really for your reference. If you see the for your reference up there, that just means you have homework, and I expect you to turn it in tomorrow by 8 a.m. No, I'm just joking. But anyway, this is for you to go and have a look at and reference. But I just want to point out a couple of things. This is just really a comparison between VPN and mobile and remote access. So a couple of things I'll just sort of point out here. One is that there's some things that aren't supported over mobile and remote access, just some of the functionality that you would have on-prem that is not available over mobile and remote access. CAPF enrollment, putting a certificate on a Jabber client, you're not able to do that over mobile and remote access. You have to do that on-prem. And we'll talk a little bit, actually no we won't, but there are some abilities using some new technology that we have not to have certificates on those endpoints to be able to do secure calling, but we'll leave that for another day. The other thing to note here is no LDAP directory access. Whenever we connect over mobile and remote access with our clients, we actually use what we call UDS, or User Data Service, and that's basically directory built into Communication Manager, so we do that rather than LDAP. The other thing I want to point out, which is a new thing, is that beginning with Communication Manager and Jabber 12.5 and Expressway X 12.5, we do have the ability to do media path optimization using ICE, which is a protocol that allows us to be able to actually do point-to-point media. So in the past, whenever you've connected, whether it be over VPN or mobile and remote access, when two endpoints are talking to each other, that traffic between them, the media traffic, is always going all the way back to the Expressway C or the VPN concentrator, and then going back out in a hairpin back to the other end. With ICE, the ability is that once the call is set up, that the actual media path, rather than being hairpin back through the enterprise, can actually go point to point between the two devices. So I don't actually have to hairpin media through the enterprise like I do with traditional MRA and with traditional VPN. So that's something that's coming new. I don't have any more material or information on it, but at the end I'll talk about some of the other sessions that are going on this week, and there's a session that covers in quite a bit of detail all of that ICE capability. But that's something new, and it was one thing that I think a lot of people were waiting for, was to be able to get rid of that hairpinning and all of the sort of load that was happening at the enterprise, and instead letting those users that are outside talk directly to one another. Anyway, I'll let you guys review the rest of that on your own. All right, so that gets us through features and functions. Next thing we're going to talk about is some design and deployment types of information and some things that we need to consider. So the first thing I want to do is sort of walk through the whole self-discovery or service discovery that Jabber does. So I'm going to walk you through what a Jabber user sort of experiences normally and how Jabber connects in generally for the first time whenever we do service discovery with Jabber. And then what I want to do is then step back and talk about what do we have to do from an administrative perspective in order to enable this experience for our end users, right? There is the ability for end users to manually configure their clients. You give them all the information, they configure it, and then if they get it to work, it'll connect in. But what we prefer and what we recommend is the use of service discovery, so that the Jabber user simply has to enter their username and their domain, and then that automatically, the client automatically takes care of figuring out what it needs to connect to and does that in the background. So I'm going to show you what that looks like, and then again we'll step back and look at what do we have to do as an administrator in order to make that happen. So I'm going to show you a flow here of a Jabber user or a Jabber client using full UC. So we're not just using calling, but we're doing IM and presence, we're doing visual voicemail, we're doing the whole bang. So we already talked about how MRA or how Jabber works with its DNS queries. So again, in this case, Jabber is going to send a DNS query. In this case, I'm just showing you the Cisco UDS one because we're inside the enterprise. So Cisco UDS, that gets resolved by the corporate DNS, and the Jabber client receives back one or more IP addresses corresponding to UDS service running on our communication manager nodes. Once that happens, the client is then going to reach out to that UDS server or servers that it got in the DNS response. And it's going to get information from whichever UDS service it talks to about what its home cluster is. If we're in a multi-cluster environment, which cluster should I talk to? If it's a single cluster, then it's just going to tell me that that's my home cluster and give me the TFTP server address or addresses for that particular cluster. Once Jabber has that, it then communicates to the TFTP server and downloads the UC services profile as well as the Jabber config XML file and any configuration it has. So it's going to download that information from the TFTP server, and all of the information that's contained in that service profile and Jabber config XML is going to tell Jabber and the client what services it needs to connect to and what the addresses are for those services. And so then what should happen is that the user is going to be requested authentication and is going to authenticate against our authz server running on Communication Manager. And we'll talk about authz in a minute. It's use of OAuth, and I'll talk in some detail about what that is. But suffice it to say, we're authenticating against Communication Manager. And then once we've communicated against or authenticated against Communication Manager, then the client will go on and connect to any of those other services. So voicemail, meetings, IM and presence, all of that kind of thing. So that's how service discovery works. That's how it should sort of operate if you set everything up correctly. One thing to sort of step back when we get into hybrid types of environments where my Jabber users are, for example, leveraging WebEx Messenger for messaging or WebEx Teams messaging. In those situations, we're doing the UDS or the DNS queries, but we're also, when Jabber boots up or changes network, it also sends a query out to the WebEx cloud to see if the domain for that particular user or that client actually matches a WebEx domain. And if it does, all of the stuff that we talked about that self-discovery or service discovery happens against the cloud rather than happening against on-prem. So in this particular case, I'm actually going to log into WebEx in those hybrid scenarios, and then I'm going to get my UC service profile and my Jabber config XML for all the other services directly from the WebEx cloud. Or in the case of Teams messaging, I'll actually connect in and actually get that from Communication Manager. But the idea here is anytime I have any kind of hybrid deployment where WebEx is going to provide a back-end service, I'm actually going to talk to WebEx first, authenticate against WebEx, and then only then will I connect into the back-end enterprise services. But otherwise, the discovery piece is exactly the same from an end-user perspective. And so then again, same thing, once I've authenticated against the cloud, then I'll also communicate and connect into any of the on-prem services. All right, so how do we make that happen? How do we set this up so that this happens for our end users? So the first thing that we need to do is we need to provision devices for our users. As we talked about on the Jabber side, there are 3 Jabber device types that come into play on the mobile. Dual mode for Android, dual mode for iOS, and then Jabber for tablet, which can be iPad or an Android tablet. And then, of course, there's also CSF, which I don't have on here, but that's for desktops. But the idea is we're creating a client device type within Communication Manager for our Jabber users. Then, once we actually have that device type defined, it's no different than any other endpoint you have configured in Communication Manager. There's some product-specific things that you configure on those devices. You're going to do the same thing via the administrative interface of Communication Manager to configure those devices. One thing I'll point out with Jabber and the client devices, depending on the version of Communication Manager running and the version of Jabber that you're running, there is the potential that you may have to install what we call a COP file or a Cisco options file. And this is basically to allow your system to be able to handle the latest client's functionality and any parameters that need to be configured. So let's say I'm running Communication Manager 10, right? And I want to run Jabber 12.5, the latest version of Jabber. In order to be able to leverage all of the features and functions that are built into 12.5, a COP file may need to be installed on Communication Manager 10 in order to be able to enable those features so that I can configure some of that stuff. However, if I have Jabber 12.5 and Communication Manager 12.5, I shouldn't need a COP file because those are aligned in the same release. But just be aware, always look at the release notes for your particular version of Jabber and version of Communication Manager to make sure that there's not a requirement for you to install a COP file. But again, that's an administrative thing. You'll sort of take care of that so your users don't have to worry about that. Once we've defined the device in there, the other thing we need to do in order to enable authentication and all of that kind of thing for the client, we have to associate that device to a particular user. So we're going to assign that device to a user. All right. So that's the device piece. The next thing we have to do is set up all of the services so that we have all of that configured, and that will then tell Jabber, hey, here are the services or the places you need to go to connect and get into those services. So we do that by creating a set of UC services in Communication Manager, and each of those will correspond to some service that we're trying to provide to our particular Jabber user. So in this particular case, I've defined IM and presence, I've defined an LDAP directory, I've defined a voicemail service, and I've defined a default Jabber config file, which provides additional information to Jabber. So all of those different services or service profiles are then going to be, or services are going to be assigned to a service profile. And that service profile is a collection, as you can see here, of those various services that I'm going to assign. And then I take that service profile and I'm going to assign that to my user. Right? So then that means that whenever that user and their Jabber client connect into the system, I'm going to then pull this set of services, and that set of services is going to tell me where it is that I need to connect in. Right? Something new that came with 12.5, which will make your life a lot easier if you use Jabber config XML files, which was previously a manual process that you configured and created in Notepad or something like that, and you then imported via TFTP or FTP into your cluster so that the clients could download them. There's now an ability within the service profiles to actually define the Jabber config XML within the GUI of Communication Manager, and to be able to then allow those clients to automatically download that without you having to upload it into the system. And so you get a lot of granularity here, and this is where we have the ability to define a lot of additional stuff on top of the normal things. So if you have special directory requirements, or you have special security requirements, or different WebEx organizations that you want to combine together as part of this, all of that stuff and all of those advanced things can be done in Jabber config XML. And as you can see here, I can just go through and add additional rows of different settings. So I have lots of options that I can set outside of here. So there's a lot of details on that in the documentation, but the idea here is you can do additional configuration and sort of customization as needed. And the nice thing again with 12.5 is the ability to be able to do that all on the interface and not having to go off to a separate place to configure that and then upload it. So that's the Jabber config XML. But the whole point of all these profiles and everything again is to tell Jabber where do I go to connect to these services and what are the parameters I need to connect to those services. All right. So a couple last things that we need to do or we need to think about before we turn Jabber clients over to our users so that they can log in. Again, DNS is going to be huge. At a minimum, we need the Cisco UDS record and the corporate DNS. If we're doing mobile and remote access, we'll also need the Collab Edge one outside. The last thing we need to think about is directory integration. For Jabber, all of its communication and all of its capabilities really are focused around users, and so I need to have ability to be able to import or users or contacts into the Jabber client so that I can actually communicate with people. And the way that we do that is through integrating Jabber with some form of directory. We have two types of methods for doing that. First is common directory integration. This is sort of the default method of doing contact or directory integration for Jabber. And what this involves is basically an LDAP directory of some form being synchronized with Communication Manager usually, but the Jabber client talking directly to that corporate directory using LDAP. So that's the traditional way, common directory integration. And then the second one is UDS, where rather than talking to a corporate directory, we actually talk to Communication Manager and pull things out of the end user database. Now the key about pulling stuff out of the end user database, you still have to populate that end user database. And so most of the time that's going to happen from some LDAP directory is going to be synchronized and pushing those users into your Communication Manager. So it really comes down to, do my users pull the information from Communication Manager, which pulled it from the directory, or do I point my users directly to the directory and have them pull directly? One thing to note here is that whenever we're outside the enterprise over mobile and remote access, and I mentioned it earlier, UDS is the only way to do directory integration when we're connected over mobile and remote access. So we can have a Jabber client when it's on-prem, it talks directly to LDAP directory, but whenever we step outside and connect over mobile and remote access, that user is, or that Jabber client is now going to pull directory information from the UDS or the local database. And that's one of the reasons why it's really important whenever you do this to have your Communication Manager user database and your LDAP database synchronized so that so if the user's inside, they're going to be okay, and if they're outside, they're going to be okay. So it's something to be aware of from a directory integration perspective. One other thing, if you're doing any kind of hybrid where we're doing WebEx Messenger or WebEx Teams messaging, in those situations, WebEx is your directory. Even though you may be leveraging other services inside of the on-prem, you're still going to leverage directory from WebEx. Now, again, your WebEx user database chances are going to be built from a directory synchronization from your on-prem LDAP directory. But at the end of the day, there's a slight nuance there with the WebEx. All right, so now that we've done all of that configuration and set it all up, now the hope is that we'll get a really nice, easy sort of interface for the users when they log in the first time. So users have to have the client. They'll download those from the appropriate app store or from Cisco.com in the case of the desktop. You can also obviously distribute that if you have some form of software distribution within your enterprise. You can also go about it that way. But at some form or fashion, they need to get the client on their devices. And then once they have their client on their devices and they launch Jabber for the first time, it's going to prompt them for a username at domain. And if we've done everything correctly, what should happen is the user should get prompted for a username and password, and then it should automatically log in and connect into all of the back-end services on the back end, to the calling, to the I am in presence, to the directory, to the voicemail, and all of that. And the user shouldn't have to enter anything beyond username, domain, and password. So that's the way it should work. Now, if we didn't configure something right, or if we're just lazy and we decided, we'll just let them figure it out on their own, there is an ability to use advanced settings. If you haven't put this in place, they can click on advanced settings, and then they have to configure communication manager server, I am in presence server, Unity connection server, directory server, so they have to configure all of that manually. Not a good experience for your end user, and so again, that's why we go through and really want you to recommend using that service discovery. Going ahead and doing all of that from an administrative perspective and making it really easy on your users to just enter username, password, and be done. Okay, so a couple of other things I want to jump in and talk about here with regard to Jabber. I mentioned OAuth a little bit earlier, and the AuthZ server running on Communication Manager that the Jabber client authenticates against. So I want to jump in and talk in a little detail about this. So beginning with Jabber 11.9, Jabber began to be able to leverage OAuth, which is a standard-based framework, RFC compliant, which allows applications to be able to authorize users or the client itself for specific services on the network. And the way that this is implemented by communication, or by Cisco anyway, and most places, is the use of authorization tokens. So we'll talk about OAuth tokens. You'll hear me mention a number of times as we go through here. These OAuth tokens are actually going to be specified or provided from an authorization server. And in the case of Cisco OAuth, that authorization server is Communication Manager. And what's going to happen is Communication Manager is going to be sort of the central place for that authorization, and is going to provide those tokens. And then all the other applications that are involved here are going to actually honor those tokens, or those OAuth tokens, from Communication Manager in order to authorize the user and their client to be able to leverage or use those services. So that's a whole lot of talking, but let's actually take a look at what it actually looks like. So in this particular case, I have a Jabber user, whether they're connecting in over mobile and remote access or whether they're on-prem. First thing that's going to happen, and we talked about it, after the client downloads the TFTP information, gets the Jabber config, it gets all the information about the service profiles, it then is going to go and contact the authorization server in order to authenticate. So in this particular case, these Jabber clients ultimately reach the authorization server at Communication Manager, and the Communication Manager AuthZ server is going to actually authenticate the user. Now, how we authenticate the user is the same as before, whether that be via the local user database, just a simple password, whether that be SSO, where we're leveraging an IDP for that, or whether we're doing directory integration where we're actually authenticating against the LDAP directory. All three of those doesn't really matter, but at the end of the day, Unified Communication Manager ensures that the user is authenticated. And once the user is authenticated, it's then going to generate or send an OAuth token to the Jabber client. Right? Now that OAuth token is then going to allow the Jabber client to connect into the various collaboration services within the network, whether that be Communication Manager for calling, I am in presence for I am in presence, voicemail, Unity connection, and so on and so forth. And the idea here is that all of our other applications, Expressway C, Unity connection, IMNP, all communicate with Communication Manager, they trust Communication Manager, and therefore they will honor those OAuth token that Jabber client or that user has been issued. So all that happens when a client then goes to connect in to, say, Unity connection is, rather than requiring any kind of authentication, it simply, when it gets challenged, passes the OAuth token to the Unity connection application. Unity connection looks at the token, goes, I know this, I trust this token, and gives that client access to that service. Right? So rather than having to log into every individual service, instead, I'm just going to log in once, and then I'm going to use that token to get access everywhere else. Now, there's another piece to this in order to make this even better, and that is the use of a refresh OAuth token. So in addition to the AuthZ server giving you an OAuth token, it's also going to give you what's called a refresh token. The OAuth token is used to do the authorization. When the OAuth token expires, one of two things happens. Either I give a refresh token back and get a new OAuth token to the authorization server, or I have to go through a full re-authentication. But the idea behind a refresh token is I don't get prompted ever for username and password, or not for very often. And specifically, those timers are 60 minutes for your OAuth token, so whenever authorization server gives me an OAuth token, it's good for 60 minutes. But it also gives me a refresh token, and that refresh token is good for 60 days by default. All right? So when I go to log in the first time, I get my OAuth token. After 60 minutes, that OAuth token is going to expire, and I'm going to get asked to ask for or to request another OAuth token. And the way I'm going to request that new OAuth token is to give them my refresh token. As long as I have a refresh token that hasn't expired, I don't have to re-enter my username and password, and I simply will get a new OAuth token. So in this particular case, by default, once I hit 60 days, my OAuth refresh token is going to expire, which means the next time I connect into the AuthZ server, in order to get an OAuth token, I'm going to be asked to go through a whole full authentication again. Right? Now, these timers can be adjusted, but the whole idea of it is to be able to prevent the user from having to regularly enter a username and password, because that takes a while. And this is particularly important when we start talking about mobile and we start moving, for example, from inside the enterprise to outside the enterprise. When I have a network change like that, having to re-enter my username and my password takes a really long time if I'm trying to, seamlessly roam on a call, or if I'm trying to get to a service or whatever. So the whole idea behind OAuth, and the reason that we implemented this, was to make it easier for the clients to be able, the user to log into the client, and whenever we have network transition changes, whenever the client's running in the background and comes to the foreground, we need the client to register and log in and get authorized as quickly as possible. And so those OAuth tokens make that happen. Question?
Why not have simply a token valid for 60 days?
Sorry, say again, sorry?
Why not have simply one token valid for 60 days?
Okay, yeah, so the question is why do we need the refresh token? Why do we need the OAuth token? Why not just make the OAuth token last for 60 days? And that's absolutely a valid point. I think the key though is this provides you the granularity to decide how often you want your users to actually do authentication, re-authentication. So the whole idea behind this is if you don't care and you don't care about your thing, you can simply set that to 60 days, and then that thing will last 60 days. But the refresh token will last 60 days on top of that, right? So there's some granularity here depending on how you want to do it. But at the end of the day, you can set it to whatever you want. What we often have, though, is customers that they want to more regularly prompt their user to enter username and password. So again, you'll have to sort of monkey with that. But this whole refresh and OAuth token and refresh token is simply just built into the RFC and the capability to do that. So we implemented it sort of via the standard, but you're exactly right. I could set the refresh token to 0 and the OAuth token to 60 days, and it would behave just as it does with the default ones, yeah. And again, when we get to the end, there's actually two sessions this week that go into specifically just OAuth and this whole framework. So if you want more details, I'm gonna give you that at the end, and you can refer to that session. Because we can spend 2 hours just talking about this one thing. All right, so that's OAuth. One last thing, just so everybody's clear about this in terms of what are the requirements. So this all started happening with Communication Manager IMNP 12.0. We also backported it to 11.5.1 SU3. So once you get to those versions, OAuth is going to be sort of implemented by default within those systems, for the most part. Unity Connection 12, Expressway 8.10, and then Jabber 11.9 are the minimum requirements for OAuth. In order to set this, it's simply a parameter, an enterprise parameter within Communication Manager, within IMNP, within Unity Connection. In the case of Unity Connection, we actually have to define an AuthZ server, which is Communication Manager again, within Unity Connection. Don't have to do that with IMNP because IMNP and Communication Manager share the same database and they already are built into the cluster. But Unity Connection, you have to point to the AuthZ server in order to enable the OAuth capability. And then Expressway also has a setting to enable OAuth. And that way I can do OAuth both on-prem, and my users connecting over MRA can also leverage OAuth. All right, so that's OAuth. There is a white paper around this for deploying Jabber and OAuth that goes into quite a bit of detail on this as well. It talks about, quite a bit about the token timers and how you should set those, and gives you some guidance around that. So definitely something worth referring to down the road. So one of the reasons that we implemented OAuth, besides the fact that it's sort of standard-based and it's the way that the industry sort of seems to be moving with SSO and OAuth and those kind of frameworks, the other reason that we sort of had to do this was around Apple push notification. And Apple push notification is Apple's method on iOS devices for being able to provide notifications to applications running on the devices that may have been put into the background or have been shut down temporarily in order to save resources. And so Apple push notification is something that is basically supported with Cisco iOS devices around Jabber. Is also supported with WebEx Teams client as well on the iOS devices. But basically, it's an ability to notify the Jabber client when it's running in the background. In the past, and the way Jabber still works today, is that we maintain connectivity to Communication Manager using a keep alive on the IP socket, the VoIP socket, and we send a keep alive to maintain an IP connection. And that's the way we've always done it, sort of traditionally done it. It's the way most people do it, is to maintain that connection. However, Apple has been threatening for about 3 years now of getting rid of that VoIP IP socket keep alive capability within their devices. And so as a result of that, in order to maintain registration when the client's running in the background and all of that, we had to come up with another method outside of an IP keep alive packet in order to maintain that connection. And the answer to that is Apple push notification. So what Apple push notification allows us to do is, rather than maintaining that connection by IP, we're actually leveraging the Apple push notification infrastructure and framework in order to be able to send a notification to that device to actually wake up the application in the background and bring it to the foreground. And that's sort of the architecture that Apple has put into place. And so as a result of that, we had to implement that within our Jabber clients for the iOS so that they could take advantage of that. Now, just so everybody's clear, they've been threatening to do that at Apple for 3 years now. It was supposed to be iOS 11, then it was supposed to be iOS 12. Well, we're at iOS 12.3, I think, right now is probably the latest one, and we still have IP socket capabilities in there, and Apple push notification still hasn't been forced as a requirement. But at some point in the future, they are supposed to fully deprecate the IP capability and require us to use Apple push notification. And so as a result of that, that's why we have to talk about this, and this is why we have to recommend to everybody, at some point you're going to need to move over to Apple push notification for your iOS devices, and so just be aware of that. Part of the reason that we needed to do OAuth is because this Apple push notification service relies on the client coming out of the background based on that notification fast enough and being able to connect fast enough in order to be able to receive an incoming call. So if the client's closed or is running in the background and an incoming call comes in, I need to get it to come up to the foreground and to connect back to Communication Manager in order to be able to receive that incoming call request. And so, again, the reason we have OAuth is because it speeds up the login process and it doesn't require username and password. So as a result of that, when we send an Apple push notification, the client can pop up very quickly and receive that incoming call. Right? So that's the reason that we have OAuth, and this is why we have implemented APNS. So let's take a look at what this looks like. It always helps to see it visually, I think. So notifications for APNS, when we enable this, is going to be sent from Communication Manager and IMNP using HTTPS out to a Cisco cloud service. It's going to be an outbound HTTPS connection. You can configure a proxy if you need to or whatever to get that outside your enterprise, but it has to hit the Cisco cloud, collaboration cloud. That Cisco collaboration cloud is then going to take that notification or that message and is going to convert it into a push notification, which will then send to the Apple push notification service running out on the internet. Then that push notification service is going to forward that push notification to the appropriate device, mobile device or iOS device that it's destined for. And that's going to get pushed to the client, whether it be outside over MRA or whether it needs to go through our firewall to reach the devices inside on-prem. So that's in a nutshell how Apple push notification works from a Jabber perspective. Again, only applies to the iOS devices. One other thing to point out here is people often ask, well, how do I get the Apple push notification? What do I have to do from that perspective? The idea is whenever you take an iOS box out, take an iOS device out of the box and you do that initial setup, one of the first things that device actually does when it connects to the network is actually go and register with the Apple push notification service with a unique ID for that particular device. So all iOS devices have the capability to receive Apple push notifications, and so then we've simply implemented it on our side in order to be able to leverage that service. So in essence, how this, or what this is actually doing is, in the past, what we've had is sending SIP keep alives or XMPP keep alives to the Jabber client so that even when it was in the background, it was able to receive those IP packets very quickly. Now that we've implemented Apple push notification service, when the client is in the foreground, we'll continue to use SIP and XMPP to communicate with it, but once it moves into the background, our only method by which to reach it would be using Apple push notification, and so we'll use that to notify it's running in the background. Oops, sorry, I jumped too far. So this is the minimum versions, 11.5, SU3 or greater, Jabber 11.9, and Expressway 8.10.1. If you'll notice, same requirements here, minimum requirements as for the OAuth, because we implemented, again, all of this, the OAuth, the Apple push notification service, all that stuff sort of got implemented all at once because it's all part of making this happen, making the clients be able to log in very quickly. And then the last thing, and it is worth pointing out and emphasizing, no impact to non-iOS devices. So if you don't have iOS devices, you don't have to worry about this. If you have Android, desktop, all that stuff, they operate just like the SIP, XMPP keep alives. That's the way all the rest of those work. It's just the iOS devices this impacts. Right? But the whole OAuth, the fast login capabilities, all of that applies to all of the clients, but Apple push notification just for the iOS devices. Any questions on that before we move on? No? Okay. All right, next thing is call routing with our dial plan within Communication Manager. That's going to determine, obviously, how we route calls from a Jabber perspective because we're leveraging IP telephony there. 2 calling search spaces come into play when it comes to Jabber, and really the same search spaces apply to unified mobility as well when we are routing calls using single number reach, mobile voice access, 2-stage dialing, those kinds of things. So we have 2 CSSs, each of which does controls things. First is call origination. The CSS that determines that is the line level CSS, the device level CSS in concatenation with the line level CSS. So this is the calling search space when we route calls to the device. So when we route calls to Jabber, when we route calls to any place where we make a call. So anytime we make a call, we're going to use that. However, call termination, when we receive a single number, I'm jumping ahead. 2-stage dialing, dial by office and voice and video over IP are what we're using that calling search space for. But the one that I want to make sure people understand is the rerouting calling search space. This is the one that determines how we route calls to the mobile. So whenever we route a call, single number reach to a Jabber client or to a mobile device, we're always going to use the rerouting CSS, not the device level CSS. And this often confuses people because they don't set the rerouting calling search space, they just leave it as none, and therefore when they go to do single number reach, the client doesn't actually ring or the device doesn't ring. And that's going to be needed again for single number reach. So here's the configuration. We got the calling search space there, and then we have the rerouting calling search space. And so 9 times out of 10 when we see issues and people call into TAC, it's because they left the rerouting calling search space as none. And then they always complain, well, why is it that you have 2 calling search spaces? Couldn't you just use 1 calling search space and save us the trouble? And the answer is probably so, but they did this to be granular and to allow you to have control over what devices you could call with single number reach and versus what devices or numbers that a user actually using the client can actually call. So that's why we have the difference. Most of the time, most customers have those configured exactly the same. But sometimes they don't, for example, want somebody to configure an international number as a mobile number, as a single number reach number, because then every time you call the user's enterprise number, it makes an international call, and so that can be problematic. So they often will do that if they have a concern about that. But generally, most customers just configure them the same. But just something to be aware of. A couple other things, emergency calling. This one comes up a lot in terms of when we do have an emergency calling and we're on these sort of mobile clients. What's the, how do we handle those emergency callings? How do we find location? How do we route the call, et cetera? So generally, our guidance on this is that a mobile network on your mobile device is probably going to provide better location information than a device that's registered remotely via IP to communication manager and that kind of thing. So our recommendation generally is, whenever possible, it's always better to route a call over the mobile network than to route it over the IP network. And for that reason, we actually have a parameter or a mechanism within the Jabber clients and those dual mode devices to actually escape or force calls to emergency numbers out over the cellular interface of that device rather than using the IP interface of that device. So there's an emergency numbers field under the product configuration layout for the Jabber device, dual mode devices in Communication Manager. And any numbers that we put in that field will be dialed directly over the cellular interface. So 911, 112, 999, whatever emergency number you may have, you can put those in there. And that way, those will get dialed directly over the PSTN or the mobile network. Now, obviously, if you don't have a dual mode device, if it doesn't have a cellular interface, in those particular cases, your only choice to route a call is going to be over the IP network. One last thing before we jump in and start talking about cloud, and that is around wireless, and particularly the experience that we provide for our users. As we talked about with these mobile clients, the connectivity is typically going to be either Wi-Fi or mobile data, and the quality of experience, voice video quality, as well as just the general response time is going to be very, very much dependent upon the quality of the network that we're connecting over. And so obviously, the difference between a wired and a wireless network is pretty significant insofar as we have no control over a wireless network insofar as it's a shared bandwidth. There is no priority servicing, no bandwidth guarantees on a wireless network like we can get on a wired network. And so as a result of that, the more control we have over the network, that wireless network, the better experience we're going to be able to provide for our users. We can optimize that wireless network if it's in the enterprise. We can set up QoS bandwidth and other types of configuration settings to make that a really, really reliable, very, very sufficient network for being able to provide good quality voice and video. So that's what we would like to do, but the problem is that we have less control as we step outside of the enterprise. As we get into public-private Wi-Fi hotspots, we have almost no control over those. And then obviously, when we get out into the mobile provider network, even less control. And then, of course, it's all going over the internet when we're outside the enterprise, so our ability to control and provide quality from a network perspective becomes less and less as we move outside and we have less control over it. And the whole point here really is to just be aware that you are connecting potentially over the internet or over unmanaged networks that don't have guaranteed bandwidth, don't have priority servicing and those kinds of things, so your mileage is going to vary here. But it doesn't mean that we shouldn't, when we're inside the enterprise, do the best that we can on our enterprise wireless LAN to provide good quality. And then we want to think about things like over-provisioning and increasing bandwidth at our ingress and egresses in order to make up for some of that lack of control that we have over those networks. As far as inside the enterprise for the networks that we do control, we obviously want to be cognizant of how that network is configured and set up. Obviously, we need to conduct a wireless LAN site survey. This is a requirement anytime we put in a wireless LAN, but particularly when we're doing voice and video. And so we do this to ensure that our radio frequency design is good, to make sure that we've eliminated sources of interference, and that our devices are going to be able to connect quickly, and they're going to be able to connect with good quality. And so from a radio frequency design perspective, we sort of have three targets that we always talk about when it comes to setting up an enterprise wireless. The first is channel cell radius of -67 dBm. or less. And the reason for that is we want to keep our channel cells at a size where we minimize packet loss on the edges of our channel cell, on the edges of the network. And so by doing the 67 dBm or less, we get less packet loss on those edges. Next thing we need to do is make sure that we don't have any interference from same channel APs. And so we want to make sure that we have 19 dBm separation to avoid co-channel interference between two APs broadcasting on the same channel. And then lastly, we want to make sure that we have overlap of our non-adjacent channels by at least 20%, so that as we move from one location to another, we're able to associate to the new wireless AP before we lose connectivity to the old AP. And so all of these things are sort of standards, sort of recommendations around making sure that you have good voice and video quality on your wireless LAN. So all of that's important. And then lastly, what about call capacity? Obviously, finite amount of bandwidth within your wireless network, and as a result of that, you need to be cognizant of how many actual voice or video calls can I get over a particular channel cell or over an SSID. Best case scenario, and these are best case scenarios, you could have a maximum of 27 simultaneous voice calls on a 5 gigahertz channel, or a maximum of 8 simultaneous video calls on an 802.11 5 gigahertz channel. Now, obviously, your mileage is going to vary from a video perspective based on your frame rates and that kind of thing. So you may get more than that with lower quality. You might get less of that if you start to get into high def, ultra high def, and those kinds of things. But generally speaking, these are some sort of targets to be thinking about. And of course, this is important to understand because based on your call rates, you may need more dense deployments of your APs so that you can provide more bandwidth and capacity on that wireless network to be able to handle that additional call load. All right, so this is kind of a game of determining how many calls you're going to have on that network and then being able to design your network appropriately so that you have the appropriate capacity. And again, we could spend hours just talking about this one thing, and obviously we have lots of other stuff to talk about, so we're going to move on. But before we do, any questions about wireless or anything else that we've talked about before we jump into cloud and hybrid? So we got about 30 minutes, and we're doing right on time. So let's jump in here and talk about cloud and hybrid. So here we're going to talk about WebEx, specifically WebEx Teams and all that kind of thing. And from a hybrid perspective or an architecture perspective, first and foremost, WebEx and WebEx Teams is a cloud-based offering. That's predominantly what it started as. It's cloud-based. However, that doesn't mean that we can't also use that in tandem with on-premise capabilities and leverage, for example, messaging from, as we talked about, leverage messaging from there, but leveraging calling capabilities and other things potentially from on-prem and the collaboration services there. So very similar to what we can do with Jabber in terms of hybrid, cloud, and on-prem. So from a feature and functionality perspective, I'm going to dig into sort of the integrations between on-prem and WebEx, specifically in these sort of hybrid deployments where we're getting the best of both worlds, getting some on-prem, getting some cloud. So first off is directory integration and being able to integrate your enterprise directory with the WebEx cloud and the WebEx organization. And so what we're doing here is basically synchronizing our on-prem or our corporate directory with our cloud organization within the cloud. And so the way that this works is using what we call a Cisco directory connector. This is a Windows server, part of your Windows domain within your network. And basically here we're going to run a piece of software which is going to basically allow us to synchronize the directory from our Microsoft Active Directory or our LDAP directory, in this case Microsoft using Microsoft APIs. We're going to import or sync users from our LDAP directory into directory connector, and then our directory connector is going to use HTTPS to push that information into the identity store for my particular organization in the WebEx cloud. So again, as I talked about earlier, anytime we talk to the cloud, we're using HTTPS REST in order to make that communication. Whatever we do on the inside will be the traditional LDAP or SIP or whatever. So in this particular case, again, sending those users in. Why do we care about that? Well, there's really two reasons we want to put our users in our identity store within the organization in the cloud. First is it allows our Teams users or our clients users of cloud clients to be able to search the corporate directory to find the contacts. Just like we talked about with Jabber, really everything's about communication and collaboration. We collaborate with individuals, with contacts, and we need to be able to have some method for finding those contacts. The same applies on the cloud side as well. The other thing it does is it also allows the administrator, once those users are in that directory, to be able to provision those users and license those users for various cloud services. So it's also an ability to allow us to actually administer and provision. All right, so that's Directory Connector. Now I want to talk about some other integrations that we can do, things like calling, messaging, calendar, and those kinds of things. But all of the other integrations that we do outside of the Directory Connector involve what we call the ExpressWay-C connector host. And what this is basically a gateway for all intents and purposes. It's just like a regular mobile and remote access or a B2B expressway, except its function is specifically to be able to provide interop between the WebEx cloud and your on-prem capabilities. So similar to the Directory Connector, except it's a set of software running on an expressway node instead. And this allows us to do integrations of things like messaging and calendar between on-prem and the cloud. So the way that this works is, again, our connector is going to talk HTTPS between on-prem and the cloud, and then is going to talk in some, sorry, I think I jumped that. And then it's going to talk in some form or fashion to our back-end applications using appropriate protocols. So first we'll start with the enterprise calendar integration to show you what this looks like. So in this particular case, you can see here I've got an ExpressWay-C connector host, and running on that connector host is what we call a calendar connector, and that is what's going to allow us to do an integration between our on-prem calendar and our calendar services running in the cloud for our particular organization. So it's going to take user information, meeting information from Microsoft Exchange or O365 using HTTPS. It's going to pull that information into the calendar connector. The calendar connector is then going to take that information and use HTTPS to push it into the cloud, into the calendar service there in the cloud. Something to note here, not only can we do that from on-prem Exchange or O365, but we can also leverage cloud-based hybrid calendaring, where that actual calendar connector up here actually gets run in the cloud and is run by the WebEx organization rather than having it on-prem. So if I do Google or O365, I can do hybrid connectors as well, but in this particular case, I happen to just be showing on-prem calendar connector with Microsoft Exchange. All right, so why do we want to do that? Well, so what this allows us to do when we do this integration is allowing us to leverage WebEx Teams, the spaces and the messaging capabilities in concatenation with the calendaring and meeting capabilities. And what this is going to allow us to do is specify an @Meet or an @WebEx in our Outlook meeting invites such that we automatically configure a WebEx Teams space as well as a WebEx Teams meeting, or we can set up a regular WebEx meeting for these particular meetings. So whenever a user goes in to set up a meeting, they just simply type @Meet or @WebEx into the location field, and that's going to automatically provision and configure a meeting for that particular event. So that's what this calendar connector capability and this calendar integration is going to allow you to do, is to be able to leverage those notations and to be able to automatically configure and provision those conferences or those meetings. So that's calendar connector. Next thing we want to talk about is messaging connector or message integration. I mentioned this early on when we were talking about the various options for hybrid messaging, and this is a new thing that's available with 12.5. And the idea again here, we're going to leverage our connector host again, but this time it's going to be a message connector. But the idea is the same. It's the same kind of function. In this particular case, I'm going to use XMPP for my IAM and presence server up to the message connector running on the ExpressWay-C connector host, and then again HTTPS from the connector host out to the cloud, and in this particular case to the messaging service within the cloud and in my particular organization. And then you can see here from a client perspective, WebEx Teams users are going to talk HTTPS to the messaging service. Our Jabber clients are going to talk XMPP to the IMP on-prem server, and then that connector is going to allow the message interchange between our cloud clients and our on-prem clients. So that is messaging integration using the message connector. And again, WebEx team users can one-on-one with Jabber users. We also get some presence information, typing, is typing, read receipts, and those kinds of things, and then vice versa. Jabber can receive or send one-to-one messages with WebEx Teams users and be able to get information about availability as well. All right, last thing I want to talk about as far as services are concerned with this, and that is hybrid services around enterprise calling. Things have evolved a bit over the last 6 months and are going to continue to evolve in this particular space. So previously, like last time I was here, when we talked about this, I had stuff around the hybrid calling, and it's user-based hybrid calling. It enables the integration for on-prem users to be able to call cloud users and their clients, and vice versa, cloud users to be able to call on-prem devices and users. And so that had two components, this particular calling integration, call service aware, which was basically the ability to do WebEx Teams desk share or screen shares while you're on an enterprise communication manager call. And then call service connect, which was again the ability to be able to have a call that comes to your enterprise line being extended to your WebEx client, and vice versa, a WebEx client being able to call in and be able to talk to an on-prem user. So all of those capabilities are available with the call connector capability. It's a user-focused sort of solution. And the thing that I pointed out here down here is that it leverages unified mobility single number reach. So all of these capabilities leverage that concept of an additional number, in this case a SIP URI, which happens to be a cloud destination in the WebEx cloud. We call the enterprise number, and in addition to ringing a mobile cellular number, we will also ring that SIP URI to connect out to the cloud and reach the user. And that's the way this has worked previously. So, whoops, I went too far. So today, we have what I would say is places-based hybrid calling rather than user-based hybrid calling. And there's a couple of reasons for this. One, we've recently gotten rid of call service aware. There's a document I'll show you in a minute, which basically talks about the fact that we've sort of removed that feature and function out of our hybrid calling capabilities. So really, what that has basically meant is that now this calling integration is really more about providing capabilities for room systems, for places within the WebEx cloud, what we call room systems, usually on the on-prem side, and being able to allow devices, room systems that are registered to the cloud to be able to call other devices that are registered on-prem, other room devices or other users for meetings and those kinds of things. But the point here is that we're sort of de-emphasizing user-based calling integrations with hybrid calling and instead looking into the future to do client dual registration. And in this particular case, rather than having a WebEx Teams user call through the enterprise using hybrid calling, instead we could have that WebEx Team user's client actually register to Communication Manager for IP calling, similar to Jabber. And then if it's outside the enterprise or I don't need Jabber calling, I can then register to the cloud for cloud calling capabilities. So as a result of that, we've basically shifted from hybrid calling and that calling integration with Call Service Aware, Call Service Connect, to leveraging that simply for our room systems, and then all of our user-based client types of things, leveraging this concept of client dual registration. However, we're a little bit a ways from this piece, the whole future, right? That's down the road. So right now we're sort of in this space right here. And what that means is I still can use Call Service Connect for my end users, not just my room systems, and people are still doing that. But the direction, as you start to think about this, is really moving towards client dual registration. So just something to be aware of. Call Service Connect will continue to stay around for WebEx, for room systems on that, but we're really moving towards more of a client strategy for the calling integrations and for hybrid calling, right? So stay tuned on all of that. As I said, the Call Service Aware went away. That's the article that goes into the information about that. So if you were familiar with that feature, now that's gone, that provides some background information there. If you never use that feature, then you don't have to worry about it. Just ignore it and move on. All right, so a couple of last things around design and deployment here. First off, Just as we did with the Jabber, we want to do a bunch of work from an administrative perspective in order to allow our users to provision, and we want to know what we have to do from a configuration perspective. So how we provision users and how we provision WebEx Teams clients and all that is really all done from an administrative perspective using the WebEx Control Hub, which is a cloud-based or internet-based portal for us to be able to manage our WebEx Teams organization, similar to what we were able to do with our WebEx organization as well. So online ability to do that. So what we're going to do from that WebEx Control Hub is the ability to onboard users, and we do that again once we brought the users into the organization using directory integration. We now have those users and we can actually provision them and license them for messaging services, for call services, for meeting services, and so on and so forth. And whenever we do that from an administrative perspective, that's going to send a provisioning invite or email to the user with information about how to get the client and what they need to do in order to get that client enabled. We can also add a user to the WebEx Teams into the organization by simply adding the user to a space or creating a new space with that user. So someone that has never used WebEx Teams, if they're in your organization and you send them a space request or add them to a space, they're automatically going to receive that same email telling them, hey, somebody wants to communicate with you, download the client, install it, and you can communicate with them using WebEx Teams. So pretty straightforward in terms of that. How do the users actually get that client? They're going to download it from again, that email will typically have that link, but they can also get it from Cisco webex.com/downloads.html, and that's going to give them the ability, based on what it is what they connect to that website. It will tell them whether they want to download desktop because it recognizes a desktop or a mobile, and so on and so forth. But each of those available, downloaded from the cloud or from the App Store. Get them on the device just as before. We can also do this same functionality without a client by using a web browser. So we can also leverage all these capabilities using web browser, and if we're doing the calling with WebRTC capabilities built in there. Once a user has the client, they're simply going to log in with email and password. And again, just like with Jabber, it'll go out, find the right cloud instance based on the domain, and go and register that user automatically into the cloud and connect them in to be able to leverage the client for calling, for messaging, for meeting, and so forth. So in terms of, just to give you sort of what this looks like from an administrative perspective, so again, I've got my users. They've been brought into my directory. I can click on any of my users, and I can activate them or deactivate them for various services. And it's really just as simple as a little toggle, just turn it on, turn it off for each individual user. I can also do this in bulk. So rather than doing it one at a time, if I have 1,000 users, I can turn them all on for calendar service or for message service, and so on and so forth. But this is how we go about managing, provisioning users for services. So similar to Communication Manager, it's just web, internet-based as opposed to on-prem based in terms of how we do that configuration. Just really quickly go through and show you some of the configuration for the various connectors that we talked about. Here's your directory connector. This is that software that runs on the Windows domain box and does integration from your LDAP directory, brings in your users. You can map different attributes from your LDAP directory into the cloud directory, and you basically specify where in your LDAP organization you want to point, and then you basically pull those into the directory connector. You set up your syncs, and it automatically pushes those users on a periodic basis into the cloud. As far as the other connectors that run on the Expressway C connector host, if you're familiar with Expressway interface at all, it looks exactly the same as regular Expressway. There's just some additional menu items within the menus. And here we're going to set up our various connectors. So in this particular case, your calendar connector, specify my WebEx organization, I specify my Exchange servers or my O365 servers, depending. And so that's how I'm going to do that. Same with the message connector, same idea. I'm going to go there. I'm going to configure my I am in present servers, local I am in present servers, so that Expressway can talk to them. And then I can then be able to communicate out to the cloud as well. So this is where all of that stuff is done from a connector perspective. On the Expressway side, there's also some configuration and visibility so that you can see statistics and all of that on the actual WebEx Control Hub where we did our provisioning. I can also see my Expressway connectors, and I can do various things there, upgrade them, and those kinds of things as well. One last thing around scalability for our expressway hybrid services. What I'm showing you here are the various expressway platforms and then the various services that are available from a hybrid perspective. Notice that these are all dedicated node capacities. All right? If you start to combine these together, which you certainly can, I can have calendar, call, and message all on the same connector, but obviously when I do that, my individual per node capacity reduces for each of these individual services. But as far as an individual service, if I have a dedicated node for calendaring, I can do 2,500, for example, with my small and my medium OVA, and I can go up to 6,000 with the large OVA or the CE 1200, and that applies across the board with these different things. So something to keep in mind. There's a lot of information, more details if you want to do like co-residency, and also if you want to run these hybrid services with, say, mobile and remote access or business to business, you could also do that, and all of the information about how those interactions sort of work and what it does to your capacity are covered in that doc. Another thing just to point out with WebEx Teams, which is sort of different than Jabber, and that is the ability to automatically hand off calls between the Wi-Fi and the mobile data network on those mobile devices. This can automatically happen just because of the fact that it is cloud registered clients. We have the ability, whether we're moving between wireless LANs, enterprise to public, or whether we're moving from mobile data to a Wi-Fi or vice versa. In all of those situations, the call will maintain and continue up as the client shuffles from one network interface to another. One thing I will say, whoops, I jumped forward. One thing I will say is on occasion you may notice, typically it's seamless, but depending on how quickly and what network you're switching over to, in some cases you may notice, the other side may notice a half second of a dropout or missing a little bit of audio before it retransitions. But generally speaking, it's not even perceptible. Last few things around Cisco WebEx Teams, scalability and capacity types of stuff. So from a WebEx Teams perspective, from a cloud perspective, in theory, it's unlimited users, unlimited spaces or rooms. Because it's cloud, it's elastic. We just keep adding more processors and more instances of our services, and so this in theory has infinite scale. Having said that, there are some restrictions in terms of how many users can be on a particular call or meeting, so a maximum of 75 users on a WebEx Teams call meeting. Obviously, if I want to go more than that, I can always go to a WebEx meeting, a full WebEx meeting, and I can get much higher than that. If I'm not in a paid organization, if it's a free organization, I can have up to 3 on a particular call. And just so everybody's aware of that. High availability, because it's cloud, it's highly redundant, highly resilient. If we lose services within a particular data center, we always have backups elsewhere. In the case of our hybrid integrations where we need that connector, we have redundancy there for our expressway connector hosts. Also our directory connector, that Windows domain box, we can have redundancy there as well. So if we lose one, the other one can pick up and cover those services. And of course, when we talk about our mobile devices, we also, in a dual mode situation, we always have the ability to fall back to our cellular interface as a worst case scenario in those particular scenarios. Last couple of things here, push notification, all the stuff we talked about, Apple push notification around Jabber, the same stuff applies on the WebEx Teams side. WebEx Teams actually has used APNS basically from the beginning on the iOS side. So anytime the client goes into the background from a WebEx Teams perspective, it uses APNS in order to notify and bring the client back up. So all of that stuff applies. Same thing with all of the wireless stuff that we talked about in terms of wireless site surveys and the ability not to have much control when it's outside and only having control on the inside. That all applies to WebEx Teams as well. If those users are coming inside the enterprise and leveraging the wireless network for making and receiving calls, obviously we want to make sure that's in good shape so that they get good voice quality and good video quality. All right, so that gets us to the end. Again, the whole idea behind all this, hopefully it was clear that Cisco Enterprise Mobile Collaboration really provides this concept of any collaboration service, whether it be calling, messaging, meeting, sharing, across any device, mobile, tablet, desktop, web, and no matter where you happen to be, whether it be home, work, on the go, whether I'm connected over Wi-Fi, whether I'm connected over mobile data, and whether I have a purely on-prem deployment, whether I have a purely cloud deployment, or whether I'm somewhere in between where I'm taking some on-prem and some cloud, even in a hybrid deployment. We can do this any service, any device, any location. So, a few slides here with additional resources, everything from unified mobility and Jabber documentation, including the OAuth information, Expressway, mobile and remote access information, WebEx Teams, WebEx hybrid services, and of course deployment guides around WebEx hybrid messaging, since that's new, hybrid preferred architecture for Cisco WebEx hybrid services. That's a whole Cisco validated design that goes through step by step what you need to do to enable all of this stuff. WebEx mobile client, Cisco meeting app, product documentation, all listed here for your reference. So if you have anything you want to look up or whatever, you got that there. Any questions, feel free to reach out to me in WebEx Teams space, or you can just reach out to me in my email address, mmatt.jordy@cisco.com. Please complete your survey. Again, let us know if this hit the spot, if you want to see other things added, if you want to see things taken away, et cetera, please provide that feedback. Continue your education. Just real quick, want to point out a few related sessions that, thank you, that have happened either earlier in the week or are going to happen either later today or tomorrow. So these would be good places to go if you want more information on some of the topics we covered. Everything from the OAuth stuff. Again, there's several sessions that cover OAuth, in particular 2699. Obviously, it's already happened, but you can always go into the catalog and pull down the slides and review them. Securing Expressway, B2B, and cloud communications. That also covers MRA and all of that stuff, so a lot of the Expressway stuff we talked about. Cisco Jabber happened yesterday. Also good stuff to check out. External collaboration and federation with Expressway. That goes into some stuff around ICE and all the point-to-point media and some of the things going on there. And then if you're interested in more cloud and hybrid integrations, I highly recommend 2607, which is later today. It goes into a lot more detail around a lot of that hybrid stuff that we talked about, in particular the calling and sort of where we're going direction-wise with that. And then some advanced stuff around OAuth, authentication, and a lot of the sort of nuances and sort of details around the OAuth token, the refresh token, all of that kind of capability, some of the fast login and what it is that whole thing is sort of meant to do. That's another good session. That's tomorrow morning. So I think that gets us to the end. I'm happy to take any questions if anybody has any. Otherwise, thank you very much for your time. Enjoy the rest of your week here at Cisco Live, and have a good day, okay?